Welcome to CW 1.3. Today we're going to be reviewing all the forms of lines and also going over average rate of change. So let's get right into it. The first one we want to review is slope-intercept form. So this is something all of you should be pretty familiar with. That's just y equals mx plus b. The next one is point slope form. And this one might be less familiar, but hopefully you're seeing that it's very, very helpful and useful. That's just y minus y1 equals m times x minus x1. And the last one we covered is probably the most unusual one that's really not super useful, but it's important to know like what to do when it happens. This is general form. That's ax plus by plus c equals 0. Couple stipulations. A, b, and c are relatively prime integers, and a is usually positive. Okay, so those are three forms we've gone over. Let's do a couple more examples today. So first example, write an equation of the line passing through negative 3, 1, parallel, let's highlight that. And it's parallel to the line whose equation is y equals 2x plus 1. Write the equation in point slope form and slope-intercept form. So to do this, it's not too bad. If it's parallel, recall that would mean that the slope is the same. So parallel, that simply implies same slope. So the slope we're dealing with here is 2, since I can see that there's a 2 right there. And then it says it passes through a point given. So we should clearly start with point slope form. So let's just write that out. You don't have to do this part if you're comfortable. I'm just writing it out in case you like showing steps. Y, the point is negative 3, 1, so let's write y minus 1 equals the slope, which is 2, times x plus 3. Let's box that. And right there, that's our point slope form. We also want slope-intercept form, so that's not too bad. We just simplify this thing. So that would be y minus 1 equals 2x plus 6. So y should equal 2x plus 7. We'll box that. And again, we'll write SI form. It's not too bad. Let's try our next one. Find the slope of any line. So looking for the slope that is perpendicular to the line whose equation is that. Okay, so recall that for perpendicular slope, that simply means opposite reciprocal. So for this one, let's grab that equation and let's solve for y. Let's put it in slope-intercept form. So 4y should equal negative x plus 8. So y should be negative 1/4 x plus 2. So we can see here that m is negative 1/4. Then what you do is you say the perpendicular slope, so m perpendicular, that's an upside down t essentially, do the opposite reciprocal, which would be 4. So this is the slope we want to use for the question. Okay, now we go to part B. That was part A. To write the equation of the line passing through 3, negative 5, and it's perpendicular to the line we just worked with, which means we're going to use that slope 4 and the point. So let's plug it all in. So y plus 5 is equal to 4 x minus 3. Now notice how we actually can't leave it like that because it wanted us to find general form. So to do that, let's multiply it out. Y plus 5 equals 4x minus 12. Now normally we'd solve for y because we want slope-intercept form, but it says general form, which means we just want the equation to equal 0 while keeping our x term right here positive. So move everything to the right side. 0 is equal to 4x minus y minus 17. And there we go. That would be our general or standard form. Okay, the last concept for today is average rate of change. And if you've taken physics or you're in physics, hopefully you remember that anytime you see that, that really just means slope. It's like a really fancy way to tell you to find the slope. So it says find the average rate of change of this graph from x equals 0 to x equals 1. So of course we know to find slope, we need 2 points. So think of it as they just gave you 2 x coordinates. So right, 0, comma something, 1, comma something. And all you gotta do is figure out, well, what's that question mark? Well, luckily they gave you an equation. It's just x squared, which means if you plug in 0, square it, you get 0. Plug in 1, square it, you get 1. Calculate the slope, so that's just 1 minus 0 over 1 minus 0. So there's your average rate of change from 0 to 1, right there. Now, of course, that's pretty straightforward, so I want to give you a little more context on pre-calc. What you just did, let's just plot 0, 0, and 1, 1 right here. Here's 0, 0, here's 1, 1. What we just did is we calculated the slope between these 2 points, or average rate of change. So draw a line like that. We just found that the slope of this line is 1. And in calculus, you're going to learn that this line is actually called the secant line, and that word might also look familiar from trigonometry. It's somewhat related, not the exact same thing as a secant function, but this is called a secant line, essentially when you connect 2 points on a graph like that. So let's do a couple more examples here. We'll go to B from 1 to 2. So 1, 1. This would be 2, 4, once you square it. Hopefully some of you can just do the slope in your head. That shouldn't be too bad for you. So that would be 3 over 1, which is 3. Let's draw in the secant line. So I'll do this one in red. 1, 1 is right here. 2, 4 is right here. I'll connect them. So again, that's called your secant line. And we just found the slope of that line was 3. I'll do the last one in black. So we have our points negative 2, 4, and 0, 0. Let's calculate the slope there. So that would be negative 4 over 2, which is negative 2. Let's plot it. Negative 2, 4 is right here. 0, 0 is right there. We draw our line. And again, I really want to hammer that into your head. That's called the secant line. And we just found the slope of that line is negative 2. Okay, that's it. And we're going to work on some practice problems.